Rare earth metals power our smartphones, electric cars, and wind turbines, but at what cost to the planet? The process of mining these critical elements leaves behind a trail of environmental challenges that we cannot ignore. Let us dive into the hidden consequences of our tech-driven world and explore what is at stake. Welcome back to Objectified, the channel where we unpack the stories behind the things that shape our lives. Today, we are diving deep into the environmental impact of mining rare earth metals, those obscure elements that are anything but rare in our daily tech. From your phone to renewable energy tech, rare earths are everywhere, but extracting them comes with a steep environmental price. We will explore where these metals come from, how mining has evolved its cultural and global significance, some jaw-dropping facts, and what we can do about the challenges. So, grab a seat and let us get started. Rare earth metals are a group of 17 elements, including names like neodymium, dysprosium, and cerium, found in the Earth's crust. Despite their name, they are not exactly rare. Cerium, for example, is as abundant as copper. The challenge lies in finding deposits concentrated enough to mine economically. These elements were first discovered in the late 18th century in Sweden, but their importance exploded in the 20th century with the rise of technology. Today, they are critical for magnets in wind turbines, batteries in electric vehicles, and even military tech like missile guidance systems. Mining them, however, is no simple task. It involves digging massive open-pit mines or leaching chemicals into the ground to extract tiny amounts of these metals from complex ores. The process often starts with strip mining, where entire landscapes are cleared to access mineral deposits. Countries like China, which produces about 60% of the world's rare earths, and Australia have become key players. But the environmental toll, deforestation, soil erosion, and water contamination has sparked global concern. The origin of these metals is not just geological. It is a story of human demand for innovation, clashing with nature's limits. Mining rare earths has not changed much in its core methods, but the scale has grown massively. In the 1980s, the United States was a major producer. But stricter environmental regulations pushed much of the industry to China, where oversight was initially less rigorous. Today, a single mine like Bayan Obo in China can produce tens of thousands of tons annually, but at a cost. Traditional mining uses toxic chemicals like sulfuric acid to separate rare earths from ore, leaving behind radioactive sludge and polluted water. Innovations are emerging to tackle these issues. Some companies are experimenting with bioleaching, using microbes to extract metals with less environmental harm. Others are developing recycling methods to recover rare earths from old electronics, reducing the need for new mines. For example, researchers in Japan have found ways to extract neodymium from discarded hard drives. However, these technologies are still in their infancy, and recycling only meets a tiny fraction of global demand. The industry is at a crossroads: scale up sustainably or continue with methods that scar the planet. Rare earth metals are not just a scientific or industrial story, they are deeply tied to global politics and culture. China's dominance in the market has made rare earths a geopolitical chess piece. In 2010, when China briefly restricted exports to Japan over a territorial dispute, it sent shockwaves through global markets, highlighting how dependent we are on these metals. In many mining communities, particularly in China and Africa, the cultural impact is stark. Entire towns rely on mining for jobs, yet workers and residents face health risks from polluted air and water. In places like Botu, China, once thriving farmlands have turned into toxic wastelands, forcing communities to grapple with the trade-off between economic survival and environmental health. On a broader scale, rare earths symbolize our society's push for green technology. Electric vehicles and wind turbines rely on them to reduce carbon emissions, yet their extraction often undermines those very environmental goals. It is a paradox that shapes debates about sustainability and global responsibility, forcing us to question how we balance progress with preservation. Did you know that a single wind turbine can require up to 600 kilograms of rare earth metals for its magnets? Or that the vibrant colors in your smartphone screen come from rare earth compounds like europium and terbium? Here is another shocker. The waste from rare earth mining can remain radioactive for thousands of years, posing long-term risks to ecosystems. In some Chinese mining regions, groundwater is so contaminated that crops cannot grow, and locals rely on bottled water. Yet there is hope. Scientists are exploring deep-sea mining as a potential source. Though it comes with its own environmental dilemmas, like disrupting fragile ocean ecosystems, these metals may be small in quantity, but their impact is massive. The story of rare earth metals is a complex one. They are the backbone of our modern world, powering everything from green energy to defense systems. But the environmental cost of mining them, deforestation, water pollution, and radioactive waste cannot be ignored. As we push for a sustainable future, we must confront the irony that the materials enabling green tech are often extracted in ways that harm the planet. Innovations in recycling and cleaner mining methods offer hope, but they are not yet enough. It is a reminder that progress comes with responsibility, and we all have a role in demanding smarter solutions. What do you think about the environmental trade-offs of rare earth mining? Drop your thoughts in the comments below and let us know if you have ideas for sustainable solutions. If you found this video eye-opening, give it a thumbs up, share it with friends, and subscribe to Objectified for more deep dives into the objects shaping our world. Thanks for joining us on this journey into the hidden costs of rare earth metals. Stay curious, and we will see you in the next video. Until then, keep exploring the world around you.